So people were asking a lot of questions about the graph of tangent, and so I just want to make sure that we go back to our basics of what tangent is and how tangent is defined to be the sine value divided by the cosine value. You can think of that as on the unit circle, the y value divided by the x value. You can think about that as the slope of the line. And so as I rotate around the unit circle, I'm keeping track of what the slope of the line is. And whatever the slope of the line is, that is the point that I graph for tangent. And so again, you really only need your four corners here to understand what's going on with tangent. Um, some of the intermediate values, I think, might help out to understand exactly where it's negative or where it's positive. But the four corners are always a good place to start, where you have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So let's start with those. I'm going to calculate tangent at each of those places. Sine divided by cosine is 0. Sine divided by cosine is undefined. Here we have sine divided by cosine is 0. Here we have sine divided by cosine, again undefined. So if I try to start graphing tangent, I'm noticing that we have a y-intercept of 0, and then we have undefined. Then we have an x-intercept there, and then we have undefined. And the same thing would happen is if I rotated backwards on the circle. We'd have undefined, x-intercept, undefined, x-intercept. So that'd be spaced evenly. So with the four corners, we already can see that there have to be asymptotes. Now the next thing to think about is, where is tangent positive and where is it negative? Tangent's positive here because your x and y values are both positive. Tangent's negative in quadrant 2 because your x value is negative, even though your y value is positive. Tangent's positive down here again because both the x and the y are negative, and two negatives divide to make positive. Finish it out, tangent's negative right here. This should line up with your understanding of slope. If you have a positive slope that goes through the origin, it goes through those two quadrants there. Whereas if you have a negative slope that goes through the origin, it goes through quadrants 2 and 4. And that's why tangent looks the way it does. We know that tangent has to be positive because this is quadrant 1, so it's got to be positive there. This is quadrant 2, this is quadrant 3, this is quadrant 4. And so I know that we have to have positive and then negative and then positive and then negative. The last thing is that your tangent values get infinitely high as you get closer and closer to 90 degrees. Because the slope of this line gets higher and higher and higher the closer I get to 90 degrees. And the moment it touches 90 degrees, it's undefined. And so how do we show that with the graph? It's getting higher and higher and higher, approaching that asymptote. Now notice what happens. The moment I go past 90 degrees, now I have a negative slope. It's a very big negative number, so my graph picks up down there, like that. And we repeat that process over and over and over again. This should be a little bit flatter in the middle, like that. And so when you repeat this analysis of like what's going on with the slope, you can see that we have these repeating S-curves forever and ever. Now, one thing I want to point out is the domain here is a little bit annoying because it has all of these asymptotes. So one way you can write this, and this is not going to be something that's on the test, but you can write it as R with all, meaning all real numbers, and then you can slash out what you don't want. And what I hope you notice that we don't want is we don't want those intervals, those asymptotes that are like pi over 2s. And so we don't want pi over 2 plus pi n. Your range, however, is everything from negative infinity to infinity. And that's tangent.